Hi everybody, our topic is the ossicles of the ear. So we're going to talk you through the anatomy, their function, and then hopefully a few diseases that might be relevant as we come across them. So the ossicles are the three smaller bones, probably the smallest bones of the body actually, and they go malleus, incus, stapes from outside to inside. So if you look at the diagram, the red one is the malleus, the blue one's the incus, and the green one's the stapes. You might want to remember those as the hammer, the anvil, and the stirrup, because that's the shape that they represent. They're connected in a chain, and they link the tympanic membrane on the outside to the oval window on the inside. You can see some of the articulations on the slide there. They're quite detailed, so we thought we'd just let you read them. We don't think they'd probably be asked in the ESAs though. No. From the embryology that we've studied, the malleus and the incus are from the first pharyngeal arch, and the stapes is from the second pharyngeal arch. So if we move on to function next, there are two main functions. The first one is that they conduct sound waves, and the second one is that they actually amplify sound. And the way that they do that is that they conduct the sound onto a small focus on the oval window. So if you think about the size of the tympanic membrane, it's actually 20 times larger than the surface area of the stapes pedal at the end, or the foot. And the way that it reduces the amount of vibrational energy by focusing it is that if you imagine going from a swimming pool and being outside of the water and then stepping into the water, you can't hear as much when you're in the water. So if we didn't have the bone between air and the endolymph inside the ear, then the vibrational energy wouldn't be transmitted quite as well. Next, we thought we'd talk about the STAPEDIUS muscle, because I wasn't too sure about what it actually does, and it might be helpful for revision. So it's the smallest muscle in the body, and it's innervated by the nerve to STAPEDIUS, which is from the facial nerve. Its origin is the posterior wall of the tympanic cavity, and it's inserted onto the neck of the stapes, or the stirrup, which can be seen just over here. Okay, so I'll pass you on to Darren next, and he's going to talk a little bit more about the STAPEDIUS and some diseases.
Okay, so the function of the STAPEDIUS muscle is to dampen any excessive sound vibrations by contracting and stopping the STAPEDIUS muscle from vibrating too much. This function can be damaged during Bell's palsy if the lesion occurs distal to the geniculate ganglion. Then that means that the innervation to the STAPEDIUS muscle is lost. So then if you're next to a loud sound, or like in a nightclub or something, the protective function of STAPEDIUS is lost. So sound is perceived a lot louder than it would be normally. And then CHOLESTEATOMA, which has been discussed a few times already today, can affect the functioning of the ossicles. So as people have said already, it's expanding growth of keratinized stratified squamous epithelium within the middle ear. And this can either increase the pressure within the middle ear, or it can cause the release of osteolytic enzymes, which will then damage the ossicles of the middle ear. You can have congenital or acquired CHOLESTEATOMA. So congenital involves trapping of squamous epithelium within the temporal bone, and acquired is usually from a eustachian tube dysfunction resulting in a negative pressure in the middle ear. A patient will present with discharge and progressive hearing loss, and then the treatment of CHOLESTEATOMA usually is via a mastoidectomy. So you go through the mastoid process into the middle ear cavity and remove any of the squamous epithelium. And then, just to point out, that's what it would look like if you looked into someone's ear who was suffering from this. And then we notice that we've got a spelling mistake on this side. Oh no, it's been changed. We haven't anymore. So otosclerosis is where the bones become fused together and they become more of an immovable mass. So therefore, when the tympanic membrane vibrates from hearing sound, it's not transmitted easily down the chain of ossicles into the oval window. So this is an autosomal dominant condition, and it presents with hearing loss usually between the age of 10 and 30. If only the ossicles are involved, the patient will suffer from a conductive hearing loss, so therefore it's corrected with a hearing aid or a STAPEDIUS. But if the otic capsule is involved, you get a sensory hearing loss which can't be corrected through a hearing aid. And if the ossicles and the cochlea are involved, you get a mixed hearing loss which can be treated with a cochlear implant. So that's just talking about the treatments there. And then that's it.